Hello viewers, in today's class we are going to discuss one important integral involving the Dirac delta function, right? So in this session we are going to discuss this integral involving the delta function. So here we have minus infinity to infinity x square sine pi x over 4, and the delta function is given by delta of square root of x minus square root of 2 dx, right? So here we'll see how we can solve this integral using a very simple property of Dirac delta function, right? So let us start. So let us take this integral as I, right? Now, viewers, if we closely look at this integral, then here we see that this is our delta function, right? So here we have delta of square root of x minus square root of 2. Now see, there is an important property of delta function in which the argument is square root of x minus square root of a. So when we have delta of square root of x minus square root of a, then the value of this delta function is given by 2 times square root of a, and then we have delta of x minus a, right? So delta of square root of x minus square root of a is equal to 2 times square root of a delta of x minus a. So here we are not going to prove this property, but we'll directly use this property to solve this integral, right? So delta of square root of x minus square root of 2 can be written with the help of this property. So our a is 2. So we have 2 times square root of 2. Then we have delta of x minus 2. So substituting this value of delta of square root of x minus square root of 2 over here, we can rewrite this integral as minus infinity to infinity x square. We have sine pi x over 4, and here we have 2 times square root of 2 and delta of x minus 2 dx. Now taking this term outside the integral, we can now write 2 root 2, and we have minus infinity to infinity x square sine pi x over 4, and here we have delta of x minus 2 dx, right? So now let us take this function as say f of x, and here let us take delta of x minus 2 as delta of say x minus b. So now we can write this integral as 2 root 2, and here we have minus infinity to infinity. Then we can replace x square sine pi x over 4 by f of x, and here we have delta of x minus b dx, right, where b is our 2. So now we can also take this 2 as a. So here we are, just for the sake of understanding the definition of Dirac delta function, we are taking it as b, right? So now we know that by definition of Dirac delta function, the value of this integral is equal to the value of this function at this point, right? Because the delta function peak, it exists only at this point, that is x is equal to b, and b is 2, right? So we have I is equal to 2 root 2 times f of b, and b is 2, so we have 2 root 2 times f of 2. So now f of 2 can be obtained by taking x is equal to 2 in this function, right? So we have here 2 root 2, then we have 2 square, and here we have sine pi 2 over 4, right? Because here we have x and x is 2. So now I is equal to 2 root 2. 2 square is the 4. Then we have sine. This is 2 pi by 4. So we have here, we can cancel 4 by 2. So we have sine pi by 2. Sine pi by 2 is 1. So we have 4 2s are 8. So we have 8 root 2, and sine pi by 2 is 1. So we can now have I is equal to 8 times square root of 2. So where's the value of this integral is equal to 8 times square root of 2, and we have seen that how easily we can apply this property of Dirac delta function to evaluate these type of integrals.